Hello students, today we're talking about the slopes of perpendicular lines. So what are perpendicular lines? Perpendicular lines look like this. You have one line going up. One cannot see that. One line maybe going up this way. A perpendicular line would be going across it. So this line's going up. This line would be going down. And right in the middle, they have to make right angles. Okay. So the definition of a perpendicular line is lines that intersect to form 4 right angles. If I was going to write that as a biconditional, I would say 2 lines are perpendicular if and only if they form 4 right angles. Okay, that's a pretty good definition. It's pretty strong. The symbol for perpendicular lines, perpendicular is a very long word, so if I don't want to write it, I can just write this upside down T. So this would be, let's say that's line M, and that's line N. I could say line M is perpendicular to line N. All right, let's review a little bit. What's the slope of this line? The way to find slope is to say, okay, how do I get from one point to the next along the line? And what's its steepness? This slope is negative, it's going down. It's going down 1, 2, 3, and then to the right, 1, 2, 3, 4. So the slope of this line is -3 over 4. Slope of the line is -3 over 4. Let's look at the slope of a perpendicular. So draw the perpendicular going through the point 4, 2. First thing I'm going to do is go find the point 4, 2. 1, 2, 3, 4. 1. Oh, it happens to be this point. It doesn't have to be this point, but for this problem, it says draw a perpendicular going through this point 4, 2. What does the perpendicular look like? Well, this line was going down, and we know they have to cross each other at a right angle. So I'm gonna eyeball it. I'm gonna try to get that T right there. Does that look like 90 degrees on both sides? Okay, and then I'm gonna continue down. So the line I just drew, I'll make it a little bit wider. Is a line, draw the line perpendicular going through the point 4, 2. And this looks perpendicular to me. By the way, this has a positive slope. Okay, let's do some review of slope. We had some of these in the previous lesson. What is the slope of the first line? The slope is 7/3. What's the slope of the next one? Good, -4. Ooh, this one's tricky. What's the slope of this line? We'll come back to that one. How about the slope of this one? 5/3. And the slope of this one? What's the m in this problem? Y equals mx plus b. M is in front, so that would have to be a 1. And the slope of this one, also a little tricky, it's not 4. It's actually 0, because if I wrote y equals no x's plus 4, you can see that the 0 is in the place in front. Okay, let's check out this one. Let's remember what this looks like. This is a graph. This is the x-axis, and this is the point x equals 3. X equals 3 is right there. So if I have a line that's called x equals 3, it's going to be an up and down line just like this. This line is the line x equals 3. So what kind of slope is that? That is undefined. Okay, let's review yesterday. So this line is pretty steep. It goes up 7 and then right 3. So there will be a line connecting that. This is the steepness of this line. Really steep. Okay. Question is, what's the slope of a parallel? It's also going to be up 7, right 3. So the parallel line is also going to have the same slope. How about this line? This line is going down 4, right 1. So this line is pretty steep the other way. The steepness of this line is -4. That's a negative sign. What's the slope of a parallel? Parallel line is also going to be a steepness of -4. All right, what's a line parallel to this line? Also going to have a slope of undefined. Are you guys seeing the pattern? This is the parallel is going to have a slope of 5/3. The parallel line will have a slope of 1, and the parallel line will have a slope of 0. So what do we know about parallel lines? Lines are parallel if and only if they have the same slope. All right, now we're getting into the one we were just looking at, which is what is the slope of a perpendicular? Let's look at this one. The slope of the original line was -3/4. What's the slope of this new line? It's not negative. First of all, it's positive because it's going up from left to right. And how much up is it going and how much over is it going? Well, I'm going to tell you that it's going up 4 and right 3. Now, if I did this on Desmos, it might be more perfect. But the slope is up 4, right 3. That is very interesting. Slope is up 4, right 3. I wonder how those two things are related. That's the slope of the perpendicular. Yeah. What do you think this one is? This line's going up. The perpendicular's got to be going down. So it's going to be negative. And it's going to be -3/7. Is that what you expected? Okay, how about this one? This slope is going down, so the perpendicular is going to be going up. Someone in class said 4, but 4 would be too steep. It's going to be more like that. What's the slope of this line? This one is going to be positive 1/4. Should we figure this one out? What's the slope of the perpendicular? This is the original line. A perpendicular line is going to be going like that. What's the slope of that line? It's not undefined. Good, it's 0. It's 0. Okay, slope of this one of the perpendicular is going to be -3/5. The slope of the perpendicular is going to be -1. And the slope of a perpendicular line to this line, remember this looks like the line y = 4. Here's what the line y = 4 looks like. 1, 2, 3, 4. That's the y. This is the line y = 4. And a perpendicular is going to have an undefined slope. That says undefined. Oh, you see the pattern? Let's see if we can put it together and do a math problem. Find the equation of a line perpendicular to the given line. So it has to be perpendicular to this line, but go through this given point. So here's the point 2, 3. And I want to draw it so that it's hitting this line at 90 degrees. So it's going to make a T with this line. Oh, I kind of missed. Not too bad. Something like that. Okay, so is it going through this point? Yes. And does it look like 90 degrees right there for you? I think so. Kind of, sometimes I tilt my head to see if it looks like a perfect right angle. Okay, here's the steps. It's a lot like the previous lesson. Step 1 is to grab the slope from the original line. So the original line is 1/2 x minus 3. And I'm going to grab the slope. The slope is 1/2. The rest of that I don't need. Step 2, I'm going to write the slope of the perpendicular. And that's what we were just looking at in the last slide. So the slope of the perpendicular is going to be -2/1. Or we could just do -2. Okay. Step 3, use the slope and point to write an equation. I'm going to go to the next slide. So we're going to take the slope, which is -2, and we're going to take the point, which is 2, 3. So the slope was -2, and the point was 2, 3. And that's all the information we need to write an equation. There's 2 ways to write the equation. One way is to plug it into y equals mx plus b. And we're going to take these 3 numbers and we're going to plug them in here to find out what the b is. So I'm going to put a 3 for the y. I'm going to put a -2 for the m, and I'm going to put a 2 for the x. That's going to get me 3 and -4 plus something. And I'm trying to find where the line is going to cross the axis. I'm trying to write the equation of the line. The way we do this is we add 4 on both sides. Get 7 is the same as b. It's not the answer. What did we just find? We just found that this line crosses the y-axis at 7. Hey, it kind of looks like it does. Not too bad. So what's the equation of this line? The equation of this line is y equals, what's the slope? -2x plus 7, because it crosses through the axis at 7. Could I just count it and figure that out? I could have. Could have used my slope of -2 and counted and seen where it hit. Okay, so if you're showing work this way, you have the slope and you have the y-intercept. So you would put it together. If you're showing work, you would go like this, -2 for the slope and 7 for the y-intercept. That is the answer to this problem. But a little bit more sophisticated way to do this problem, just as good, just a different way, is to use the point slope formula. So we know the point. This is now going to be an x1 and a y1, and we know the slope, and we're going to plug it in. So we're going to put the 3 for the y1, we're going to put the -2, and we're going to put the 2 for the x1. I'm going to distribute. That's a plus sign. And then I'm going to add 3 on both sides. Gets us to the same exact place. We have y equals -2x plus 7. Different ways to do the same problem. You could look at the graph carefully. You could find out what the y-intercept is, and then use that in the slope to plug it in, or you can use point slope formula and then change it to slope intercept. Okay, let's practice 2 more. So we have a line given to us. What do we know about that line? We know that it goes through the y-axis at 2. That's what the 2 stands for. And we know it has a slope of -3. And that's a slope of -3. Down 3, right 1. So this is the line that they gave us the equation for. And we have this other random point, which is the point 6, comma, -1. 1, 2, 3, 4, 5, 6, -1, which is right here. Not on that line, it's kind of over here somewhere. And we are trying to write the equation of a line perpendicular to this line, but going through this point. Okay, so let me eyeball it. I'm gonna kind of make a right angle right here. I'm gonna make a T. So if I twist my head. Oh, not bad. It kind of looks like a right angle. Okay, and now I'm trying to figure out what the equation of this line is. So step 1, grab the slope. The slope of the original line was -3. Okay, step 2, figure out the perpendicular line. So this line on here, this was going down 3/1. What's this line doing? It's not down 3/1. It's definitely going up. If you're going up the line from left to right. Okay. It has a slope of +1/3. Does that look right to you? It's kind of going up 1 to the right 3. Might not be a very good drawing. I should maybe be over here a little bit more. Let's try that. That looks a little more accurate. It's hard to see these sometimes. It's hard to eyeball it. I think that actually does look more perpendicular. Okay, we'll try that. It's always good to make mistakes and adjust and keep going. Build our understanding. There's that 0.61. Okay, well, looks fine. Now, step 3, we're going to use the slope and the point to write an equation. So I'm going to do the y equals mx plus b. And the y is going to be -1. And the slope is 1/3. We figured that out. And the x coordinate is 6. And I'm trying to figure out, it might be -3. It might have, my line was kind of messy. I'm not quite sure. So let's figure it out. 1/3 of 6 is 2. And now I'm going to take away 2 on both sides. I end up with -3. So it is -3. That looks right. -1, -2, -3. Yay! This line that I was trying to write the equation for is crossing the y-axis at -3. I'm not quite done. What's the equation of the line? What's its slope and what's its y-intercept? Its slope is 1/3 and its y-intercept is -3 or -3. Okay, let's do one more. You guys are doing great. Okay, last one. This one I'm not going to graph. I'm going to just try it algebraically. So step 1, I'm going to grab the slope. Slope of this line is 3/4. I don't really care about the -5. Step 2, I'm trying to do a perpendicular. So I'm going to take this slope and I'm going to find the perpendicular, which means I'm going to take the opposite. It was positive, so my perpendicular is going to be negative, and I'm going to flip it over. It's called taking the reciprocal. Okay. Now I'm going to use the slope and point to find the equation. I'm going to stick with the y equals mx plus b strategy. The other way is just as good. This is an x and a y, so I'm going to put the -2 for the y. I'm going to put the -4/3 for the slope. I'm going to put 12 for the x and b for the y-intercept, which I don't know, which I have to find. I gotta, oh, this looks a little familiar. Remember, we're doing 4/3 of 12. my brain would probably do 12 divided by 3, which is 4. And then I would be multiplying that with this 4. So this is actually going to be negative because it's a negative times a positive. And then my brain is seeing this as 12 divided by 3, which is 4. Okay. And then that becomes negative 16. Plus something. I'm going to add 16 on both sides. The more you do these, the better you get. Put in the effort and you can do it just as good as me, if not better. Okay, I did it. I found the y-intercept and I know the slope. Now I can write my final answer, which is y equals mx plus b. In this problem, we know that the m is negative 4/3 x and the b is 14. Wow, that's an interesting answer. Kind of glad I didn't have to graph it. Graphing 14 is kind of big. I can check it on Desmos. I could type this in and I could type this in and see if they look like they're perpendicular. It's a good way to check. That's it. Be good. Do your homework. Bye.